Okay, we want to look at this integral here, e to the t divided by e to the 2t plus 3 times e to the t plus 2. And how could we solve this one? A u-du type substitution won't work out. Now, this, remember, looks like it's like in a quadratic form here, because this would be e to the t squared. Is there a way we can factor this out? We have e to the 2t plus 3 e to the t plus 2. And we have to have e to the t plus something, these are both plus signs here, times e to the t plus something. Multiplying these together gives e to the 2t, and we have to have a number here, two numbers, so we multiply them together we get 2, and we add them together we get 3, so it looks like it would be just this, e to the 2t plus 2 plus 1 is e to the 3t plus 2, so we can rewrite the integral over e to the t plus 1 dt, and looking at the problem in this form, it's obvious that the numerator is of lesser degree than the denominator. And here we have the denominator expressed in terms of its prime factors, so this should be all set for a partial fractions technique. So let's see, we have e to the t divided by e to the t plus 2 times e to the t plus 1. And these are both linear factors here, so this would equal some constant, call it a, over e to the t plus 2, plus a different constant over e to the t plus 1. Multiply both sides and we'll have e to the t equals a times e to the t plus 1 plus b times e to the t plus 2. And let's see, we collect terms, multiply and collect terms, e to the t, e to the t, so we have a plus b times e to the t, plus a plus 2b. So here we have e to the t on this side, multiplied by 1, so a plus b has to equal 1, and a plus 2b has to be 0. Let's see, so we can write this part here as minus 2b plus b equals 1. So it looks like minus b equals 1, or b equals minus 1. So b equals minus 1, then a would have to equal 2. 2 minus 1 is 1. Okay. So let's see, let's make some space here. And our integral here, e to the t divided by e to the t plus 2, e to the t plus 1 dt, that will equal, a is equal to 2, so that would be 2, the integral of dt divided by e to the t plus 2, and then b is minus 1, so we're going to have minus dt over e to the t plus 1. Let's see, let's make some more room here. Let's see, let's look at this integral first. We have 2 integral of dt over e to the t plus 2. Let's see. Can a u-du substitution help us out here? If we say let x equal e to the t plus 2 dx is going to equal e to the t dt, and there is no e to the t up here. Okay, but let's see, we can get rid of that by dividing by e to the t. Okay, e to the t equals x minus 2. Now, if I divide this by e to the t, and divide this by e to the t, so I would have 1 over e to t dx equals dt, and that's what I want to get the substitution for. The problem is on this side of the equation, we want things expressed in terms of the variable x, not t. But we have this right here. So we can say that 1 over x minus 2 dx equals dt. Okay, let's go back to our integral. This will give us dt, that's this, dx divided by x minus 2, and this is what we call x. So this integral here is now this integral, and once again, it looks like in order to get a solution, we're going to have to use partial fractions. So let's see. This integral here, when we use partial fractions, broke up into 2 integrals. We're working with this one, which again we're going to apply partial fractions. So let's see, we have 1 over x times x minus 2 will equal a over x plus b over x minus 2. We have 2 linear factors, both raised to the first power. Multiply across, and we're going to have 1 will equal a times x minus 2 plus b times x. So let's see, we're going to have 1 multiplying correct terms, we'll have a plus b times x minus 2a. So from here, we're going to have a plus b is 0. And minus 2a has to equal 1. So a is going to equal minus 1/2. And it looks like then b has to equal plus 1/2. So let's see, this integral here then is going to become a is minus 1/2, and we have 2 times this integral, so this would be minus dx over x. A is minus 1/2, but we have 2 times this. B is 1/2 times 2, so that's going to give us plus the integral of dx over x minus 2. Okay, and let's make some space, as it looks like we should be able to be in a position to solve this. This will equal minus the natural log of x. And here, again, call this u. That's going to be du, so we'll have plus the natural log of x minus 2. Great. Now what we have to do is go back and remember what x is. And we go back to here. 2 times the integral of dt divided by e to the t plus 2 will equal the natural log of e to the t plus 2. This is what x is right here. And then we'll have plus the natural log x minus 2, that would be this minus 2, so that would just be e to the t. And this one had a minus sign before it. We don't want to forget that. So that would be then this minus this, or we could write that as the natural log of this one divided by this. So we have the solution to this, that's this, and this was one of the 2 integrals that we had to solve from here. We still have now to deal with this integral here, and probably not have enough time in this video to wrap all this up. So come back, join us in the next video. We're going to find out what this integral is equal to, add it to this one, and finally we should have our problem solved. And remember now, this integral is this right here. So come back and join us in the next video, and let's see if we can get this finished.